Hi, this is Mr. Hikel. I'm back and I'm bringing you a short video on basic chemistry stoichiometry. So stoichiometry is the relationship between the reactants and products, or the reactants and products within a chemical reaction. So the first step to doing any stoichiometry problem is going to be to balance the reaction unless it's already balanced for you. So let's walk through, let's go back and let's learn how to balance this reaction. We've got calcium carbonate reacting with phosphoric acid to produce calcium phosphate, carbon dioxide, and water. So let's start by counting our calciums. We have 1 calcium going into the reaction. We have 3 calciums coming out. So right away we know we need to put a 3 right there for that coefficient. So now let's go to our carbons, our next element in the set. So we've got 3 carbons because this 3 carries through to everything behind it. On this side, we've only got 1 carbon in the carbon dioxide. So let's put a 3 for that coefficient. Now let's look at our oxygens. Well, we've got 3 times 3 right here. Over here, we've got 3 times 2, which is 6, plus 1. Well, we can get this to a 6 plus 3 fairly easily by putting a 3 there. So that makes 3 oxygens. 6 plus 3 gives us 9. So far, so good. Since our PO4 right here is in parentheses, let's go ahead and put it in PO4 in parentheses on this side because it's going to move as a phosphate. So we've got 3 hydrogens here. Here we've got 6 hydrogens because it's 3 times this 2. So we have to do the opposite. We've got to get both sides to 6. That's going to make 6 hydrogens on both sides and 2 phosphates on both sides. So now that we have it balanced, we can do the very first problem. So until you figure out how to do these very well on your own, I suggest you label your A and your B, because remember, A is what you're given, B is what you are looking for. So we are given 3.74 moles of calcium phosphate. That's our A. Our B would be moles of phosphoric acid. So phosphoric acid, moles, looking for that from moles of calcium phosphate. So first step to any of these problems after you balance it is to write down what you were given. So we were given 3.74 moles of calcium phosphate. So then everything from here on out, when I say mole ratio or anything like that, we're going to refer to the balanced reaction that we just did. So for every 1 mole of calcium phosphate, our moles is going to go on the bottom of calcium phosphate because we have to cancel out our like units. So we're going to do the opposite of that unit. So it's moles of calcium phosphate at the top. You've got to put moles of calcium phosphate down here on the bottom. So for every 1 mole of calcium phosphate, we have 2 moles of phosphoric acid. So 2 moles H3PO4. So our units are going to cancel out here. So what we're left with is this math right here. We do 3.74. We're going to take that number and we're going to multiply it by 2, and that's going to give us 7.48 moles of H3PO4. So far, so good. Not too bad. We're going to do the same thing with the next one. We're going mole to mole. So we're going to use the mole ratio. So moles of water is our A, moles of carbon dioxide is our B, 0.773 moles H2O. And we refer back to our balanced reaction. So for every 3 moles of water, we have to have 3 moles of carbon dioxide. Moles of water is on the top, so we're going to do the opposite of it. So 3 moles of water is going to go on the bottom to 3 moles CO2. 3 to 3, we can reduce 1 to 1, so it's going to be the exact same number. We don't even need to put it in the calculator. 7.73 moles of CO2. If you know you're doing these right, whatever you're looking for, we're looking for moles of CO2 will be in the top right last box that you do, or last blank. So the next one's going to get a little more complicated. This is probably the hardest one you can do with the most steps. So it's a grams to gram problem. So we got to figure out the molar mass of two different things as well. And we'll do that on the sides. So we got 15 grams CaCO3. That's calcium carbonate. That's our A. Our B is grams of calcium phosphate. Step 1, I already wrote down what we were given. Okay, so our next step, we've got to get our grams to moles so that we can use the mole ratio. And then we got to get our moles back to grams by using the molar mass. So let's figure out the molar mass of calcium carbonate. So we do that by doing Ca is 40, carbon is 12, and then we've got 3 oxygens. Each of them is a 16, so that's going to give us 48. I'm rounding these numbers for simplicity purposes. So you would use the exact number, maybe to 2 or 3 decimal digits if you needed to. So 1 mole of calcium carbonate is going to weigh 100 grams. I'm getting that number from 40 plus 12 plus 48. It gives me 100 grams. Since I've got grams of calcium carbonate up here, I've got to do the opposite and put grams of calcium carbonate right here. That takes us to our next step. We're going to do our mole ratio. I've taught you that the mole ratio is always B over A. So we know our B is calcium phosphate. So we have, we'll go back to our balanced equation at the top. We've got 1 mole of calcium phosphate. And for every 1 mole of calcium phosphate, we have 3 moles of calcium carbonate. I'm putting the 3 moles of calcium carbonate on the bottom because I'm doing opposite of my units. So calcium carbonate's on the top here. I'm putting it right here. So now we got one more step. Our grams cancel out there. I didn't cancel them out. We got one last step. So now I'm at moles of B, and I want to get to grams of B. So I've got to use the molar mass of B. So 1 mole of Ca3, this one's going to be a little bit tricky, PO4 2, okay? We got to figure out how much that thing weighs, all right? So we've got 3 calciums. We've got 3 calciums, each of them is 40, plus this 2 distributes through to this phosphorus. Well, we've got phosphorus, which weighs 30.97. We're going to use 31. We've got 2 of those. And then we're going to do that. Plus, we've got 8 oxygens because it's 4 times 2, and each of them weighs 16. So let me get my calculator. 16 times 8 plus 120 plus 62. It's going to give us 310 grams in 1 mole of calcium phosphate. So now what our math is telling us to do is to take these numbers, take 15, multiply it by 310, and then we're going to multiply by 100 multiplied by 3. So 15 multiplied by 310 divided by 100 times 3. So let's walk through it. 310 times 15 is going to give us 4,650, and we're going to divide that by 300 because that is 100 times 3. That's going to give us 15.5 grams of that. I'm not going to write it out. 15.5 grams is going to be our answer. So our last one. So we're going to do one less step on our last one because we are starting with moles of A. So we got 0.45 moles of phosphoric acid. We want to know how many grams of water are going to be made. So the same first step. Always write what you're given. 0.45 moles H3PO4. Okay? So now we start with the mole ratio. Mole ratio is always B over A. We refer to our balanced reaction at the top. So for every 2 moles of phosphoric acid, for every 2 moles of phosphoric acid, we have 3 moles of water. Awesome. So next step, cancel these out. We've got to figure out how much 1 mole of water weighs. 1 mole of water weighs 18 grams because we do H times 2 plus oxygen. Let's mark this out. So then our math would be 0.45 times 3 times 18. And then we're going to divide all of that by 2. So when we put that in our calculator, let's see, we do 0.45 times 18 times 3 gives us 24.3. We're going to divide that by 2, and it's going to give us 12.15 grams H2O. All right, awesome. So now let's look at the next 3. I'm going to go ahead and give you a bonus problem here. So this reaction is already balanced for you because it has the coefficients in front of it. So that was very nice of me. You're very welcome for that. So the next one, we want to calculate the number of moles of zinc that must react with excess of nitric acid to form 29.4 moles of ammonium nitrate. So again, always write down what you're given. 29.1 moles of NH4NO3. Then I refer to my balanced reaction. Well, I'm looking for zinc. That's my B. So I got 4 moles of zinc for every 1 mole of ammonium nitrate. Cancel the unit out. Fairly simple math. I do 29.1 and I multiply that by 4 and I get 116.4 moles of zinc. Next one, we've got how many moles of zinc, how many moles of water. So we're doing a mole-to-mole problem. We use the mole ratio again. Always write down what you start with. 18.6 moles H2O. Refer back to my balanced equation. I've got 3 moles of water for every 4 moles of zinc. So B goes on the top, so 4 moles of zinc for every 3 moles of water. So I multiply 18.6 and I multiply that by 4, and then I'm going to divide by 3. And I'm doing this with you, so if I make any calculation mistakes, it's because I'm the dummy behind the camera who decided to do this without making a key first. 18.6 times 4, we're going to divide that by 3. We should get 24.8 moles of zinc. Okay. How many grams of ammonium nitrate can be produced by using 125 grams of zinc? Well, 125 is what we start with. Okay, so we got 125 grams of zinc. Let's scoot this up. We have a little more room. We want to know how many grams of ammonium nitrate. That's our B. So first step, we've got to get this grams of zinc to moles of zinc. And we do that by using the molar mass. So 1 mole of zinc weighs 65.38 grams. I get that number because it's the number on the periodic table. Next step, cancel out your grams, not the number. The number's still important, but you're canceling out the units because you want to go to the next unit. So we got to get moles of zinc to moles of ammonium nitrate. We do that by looking at the mole ratio. So for every 1 mole of ammonium nitrate, I have to have 4 moles of zinc. So remember, it's B over A. So 1 mole NH4NO3, I have to have 4 moles of zinc. So I'm going to cancel out my moles of zinc. Remember, the mole ratio is always B over A. If it's not B over A, you didn't do it right. Now, I'm at moles of B. I want to get to grams of the B. So according to your roadmap that I gave you, you have to use the molar mass of B. So let's do the molar mass of B. So we've got 2 N's. So that's 28 because each nitrogen is 14. We've got 3 O's, which is 48 because each O is a 16. Should probably do that. And then we have, 4 hydrogens, 4 H's, which is 4. Again, I'm rounding these numbers. Use more specific numbers. So 48 plus 28 plus 4 is going to give us 80. So I've got mole here. I've got to do the opposite. So 1 mole NH4NO3 is going to weigh 80 grams. Don't worry about those. That's my work. So my math behind this tells me I take 125 and I multiply it by 80, and then I divide by these two numbers, 65.38 and 4, multiplied together. So do it with me. Do 125 times 80. That gives you 10,000. So we're going to divide that by 65.38 times 4. I did mine on a TI 83. That's my work. So I did 125 times 80, and then I divided it by those two multiplied together, which I put them in parentheses. You hit enter, and that's going to give us 38.24 grams of NH4NO3. Sorry, I ran out of them. That's basically what you do, ladies and gentlemen. So there's not a whole lot to it. If you write the units and you do a good job of labeling everything, and you understand the ratios and you know how to balance a reaction, stoichiometry is actually not too bad. It does the math for you. Remember, if it's on the top, you multiply. If it's on the bottom, you divide by whatever on the bottom. So if you have any other questions, please don't hesitate to ask.